Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are going to start another chapter of class 10th, that is probability. The last chapter of this very book, probability. Let us have a brief introduction about the chapter first. Let's have a terminology. We might use a word probability. We'll use a word outcome. We'll use a word favorable outcome. We'll use word like sample space. We'll use a word sample point or sample points. We'll use a word experiment, event, exhaustive events, we have mutually exclusive events, simple event, simple or elementary event, we can use compound event, So these are few terminologies which we may be using in this chapter. Let us start with the very basic concept, what the probability is. Probability, by the very definition, it is the branch of mathematics, which deals with the study of chance, or uncertainty. The study of uncertainty, where you are not sure or certain about something, that study is called, where you are not sure or uncertain, that means you are uncertain. The study of that uncertainty, it is called the probability. For example, you may take a coin. If you toss a coin, you either get heads or you get tails. On tossing a coin, you either get head or tail. But you are not sure, you are not certain what the outcome could be. So that means this is an uncertainty, where you are not sure what the outcome is. That study is called probability. One more example I can give. For example, if you throw a die, you know a die or a dice, you say. Die has 6 square faces, numbering as 1 through 6. When you throw a die, you can get 1, 2, 3, 4, 5 or 6, but you are not sure or certain what the outcome could be. So that means, again, in that case, that is a study of chance, and this concept of study of chance gives rise to the concept of probability. So that was a probability. Now that's next point is outcome. Now what is an outcome? Outcome means possible result. Possible result is called outcome. For example, if you toss a coin, what are the outcomes? Head or tail. So that is a possible result. Possible result or answer of anything, any question. That is the outcome of that very question. Then we have favorable outcome. Favorable outcome. Favorable outcome means your required outcome. Now you know what outcome is. Outcome is a possible result. Now from that possible result, what you needed, what you are required, that outcome is called a favorable outcome. For example, we have a coin. We toss a coin. You either get heads or tails. If I want heads, that means my favorable outcome would be head. And if I want tail, that means my favorable outcome is a tail. So favorable outcome is our required outcome. Next is sample space. Sample space. Now sample space is the set of all possible outcomes. The set of all possible outcomes is called a sample space. What do I mean by that? For example, in case of tossing a coin, we represent the set, since it's a set, we represent this set as S. So S is a set of all. In case of tossing a coin once, our outcome can be either head or tail. So this will become the sample space, the set. We generally write set within the curly braces, you know that. So S is the set of all heads and tails. So this is a sample space, set of all possible outcomes. What are the total number of possible outcomes for any experiment? That is called the sample space. Now for example, in case of throwing a die, your sample space would become 1, 2, 3, 4, 5, 6. So on throwing a die, you either get 1 or 2 or 3 or 4 or 5 or 6. Now in case you are throwing two coins together, for example, you are taking two coins and you are tossing two coins together. Simultaneously you are tossing two coins. In that case, what your sample space could be? If you are tossing two coins, so sample space is, if you toss two coins, you'll get head on first coin, head on second coin, or head on first coin, tail on second coin, or tail on first coin, head on second coin, or tail on both the coins. So that is the possible outcome for if you toss two coins together. You got it? Similarly, if you toss a coin and a die and a coin together, what your possible outcome is? What are the total number of outcomes in that case? S, sample space, is the set of all. When you toss a coin, you get head. And immediately after tossing a coin, you are tossing a die. I repeat, you are tossing a coin first, then immediately you are tossing a die. So in that case, if head appears on the coin, and then if you toss a die, you get 1 over there, or head on the coin, 2 on die, head on coin, 3 on die, head on coin, 4 on die, head on coin, 5 on die, head on coin, 6 on die, or tail on coin, 1 on die, tail on coin, 2 die, tail, 3, tail, 4, tail, 5, tail, 6. So these are the total number of possible outcomes when you are tossing a coin and immediately followed by tossing a die. So these are the possible outcomes for that. So that is the concept of sample space. So sample space is the set of all possible outcomes. Then we have sample points. When you have a sample space, like for example in case of a die, your sample space is 1, 2, 3, 4, 5, 6. This is your sample space. Now these members of the set, this 1, 2, 3, 4, 5, 6, these are the members or elements. We call these as members. We call these as members of this set, this sample space set. Members, or you say elements, or you say objects. We have different names for it. Members, elements, objects, or you can say sample points, or just simply points. So these are all names given to the members of this very set. Members, elements, objects, sample points, or points. So in short, sample points are the members of the sample space. Now let's have another one, that is experiment. Now what is an experiment? For example, you deal with a coin, study the outcome, the coin will be treated as your experiment. You deal with a die, study the outcome, that die at that time will be treated as your experiment. You do toss of coin followed by the toss of die. Now that will be treated as your experiment. Coin plus die, that will be treated as your experiment. Experiment, your deal is your experiment. So when you are dealing with a coin, that will be treated as experiment. When you are dealing with the die, that is your experiment. When you are dealing with both, that is your experiment. For example, you are studying the selection or random selection of a student from any co-ed class. So at that time, that will be considered as your experiment. So our deal is our experiment. Now after that, we have event. Now what is an event? Event is the subset of sample space. Event is the subset of sample space. This is a symbol of is a subset. Is a subset. Subset means all the points or members of E. Generally, we denote event as E. So, all the points or members of E are contained in S. That means are contained in the sample space. For example, on throwing a die, our sample space is 1, 2, 3, 4, 5, 6. That is the sample space on throwing a die. Let me take my event as, let us say, the prime numbers. So 2, 3, 5. We have 3 prime numbers. Prime numbers are the numbers which have only 2 factors, number itself and the unity, and 1. 1 and number itself, that is called unity and number itself. So E is the event. I am making the event E as 2, 3, 5. Event means my event is also called favorable outcome. Set of favorable outcome. Now you know what favorable outcome is. We are done with the favorable outcome. If you make set of that favorable outcome, that is your event. That is your event. Now if my event is 2, 3, 5, that means my favorable outcome. I want 2, 3 or 5 to happen when I toss a die. So this event would be my favorable outcome. Yes, the set of my favorable outcome. Now if I observe carefully, I am saying all the points or members of E, that means the members are 2, 3 and 5. All the members are E are contained in S. Are they contained in S? Are they contained in S? Yes. How? 2 is present in S, 3 is present in S, 5 is present in S. So that means I can say E is the subset of S. Let me give you one more example. For example, sample space for tossing a coin is head or tail. Head or tail is the sample space for tossing a coin once. Now, if I make my event to happen as head appears on the coin when I toss a coin, so my event would become H. I want head to appear on the coin when I toss a coin. So my event is, my favorable outcome is H. So my event would become E is the set of all H. Now pay attention, H is contained already in sample space. That means E is a subset of, this is called subset. When all the members of one set are already contained in the when all the members of one set are already contained in another set, that smaller set is called the subset of the bigger set, and the bigger set is the superset of the smaller set. So this is the symbol for writing down the subset. E is a subset of S. So that is our event. The set of favorable outcome is called the event. Now, after then we have exhaustive events. Exhaustive events. Now, exhaustive event is, for example, my sample space is on throwing a die. Let me take an experiment of throwing a die. So what my sample space would be? Sample space is 1, 2, 3, 4, 5, 6. So this is my sample space. Now if I want my event as the, say, let's say prime number, so I'll get 2, 3, 5. Let me make one more event. Let us say for odd numbers, you get 1, 2, 3, 1, 3, 5. Make one more event. Let us name it E3. Even numbers, so I get 2, 4, 6. Make one more event. Let us say number greater than 4, so you'll get 5, 6. Make one more event. Let us say number less than 5. Number less than 5, so you get 1, 2, 3, 4. Got it? So these are my events. I made event 1 for prime numbers, event 2 the set of all odd numbers, event 3 the set of all even numbers, event 4 the set of numbers which is greater than 4, event 5 number greater than 5. These are all events. Now first of all, you can check one thing, that every time E1, E2, E3, E4, E1, E2, E3, E4, E5, these are all subsets of S. First of all, you can check this thing, because we just we just learned that event is a subset of sample space. That means all the elements of event are contained in sample space already. See, E1 has 2, 3, 5. 2, 3, 5 is already contained in S. 1, 3, 5 already contained in S. 2, 4, 6 already contained in S. 5, 6 already contained in S. 1, 2, 3, 4 already contained in S. That means these are all subsets of sample space. After that, you can see one thing. Let us do the union of these events. E1, union E2, union E3, union E4, union E5. Let us do union of these. What do you understand by union? Union is a set when you are writing all the members of these sets collectively. That is called union of a set. For example, when I do union of all these sets, I have to write members of this, members of this, members of this, members of this, members of this in just one set. So that means E1 has 2, 3, 5. E2 has 1, 3, 5. E3 has 2, 4, 6. E4 has 5, 6. E5 has 1, 2, 3, 4. Got it? So this is my union. Now we know if any member, if any point is repeating, you write it once. For example, 2, first of all we can see we have 1, so write it once, 1. We have 2, 2, 2, write it once. 3, 3, 3, write it once. 4, 4, write it once. 5, 5, 5, write it once. 6, 6, write it once. So you wrote all the elements of this union. Now if you observe carefully, this is nothing but a sample space. Sample space has 1, 2, 3, 4, 5, 6. Our union set has 1, 2, 3, 4, 5, 6. In that case, I can say the union of all these events, all these sets is nothing but a sample space. So I can say these events are called exhaustive events. So what is an exhaustive event? Exhaustive events are the number of events, are the events where the union of these events is a sample space. You can have 10 events, you can have 20 events, you can have 30 events, you can have 100, you can have 1000 events. Now when you do the union of these events, you get a sample space. So that means at that time, if you get sample space by the union of these events are called exhaustive events. Hope you understand exhaustive events. So we are done with exhaustive events. Now we have mutually exclusive events. Mutually exclusive events. What is a mutually exclusive event? Mutually exclusive event means these are two events or more than two events where intersection is 5. For example, E is one event and F is one event. E intersection F, this is a symbol for intersection. Intersection. E intersection F is 5. 5 means null set. 5 is also written as this means empty set, or you call it null set, or you call it void set. That means it has no member whatsoever, no member here in this set. So that is an empty set. Now if E intersection F is an empty set, that means these events E and F are mutually exclusive. E and F are said to be mutually exclusive if they are disjoint. E and F are said to be mutually exclusive, if they are disjoint. Disjoint means their intersection is 5. Their intersection is an empty set. For example, let me give you an example of mutually exclusive events. Let us say, throw a die again, take similar example. So sample space is 1, 2, 3, 4, 5, 6. Okay. Now take event E, odd numbers. So I have 1, 3, 5. Now take event F of the same experiment, because my experiment is throwing a die this time. So take event F as even numbers. So I get 2, 4, 6. Now pay attention. Intersection means anything common of these sets. Is anything matching? No. That means E intersection F. Intersection is a match. Intersection means match, or you say common. For example, A is a set of all 1, 2, 3. B is a set of all 3, 4. A is a set of all 1, 2, 3. B is a set of all 3, 4. In that case, I can say A intersection B is, what is matching in these two sets? 3 is matching. 3 is common. So that means A intersection B is 3. So there is something in intersection. That is not a disjoint set. Now mutually exclusive event means where two sets has intersection phi, no member in the intersection. So here no member is matching, that means my intersection is phi. Phi means empty, no intersection, and hence E and F are said to be mutually exclusive events. Hope you understand. After that we have simple or elementary event. Simple or elementary event. What is that? Simple or elementary event means when in an event you have only one member. In an event, if there exists, this is the symbol for there exists, remember this, there exists. In an event, if there exists only one member, only one member, that is called the elementary event. For example, take a sample space of tossing a coin. So your sample space is HT. Now if your event is, let us say you want head to appear, so that means H will be your favorable outcome or your event. So if you observe carefully, this event has only one member and that is H, and that is called an elementary event. One more example, throwing a die, sample space is this. Now if you make your event 1 or 2 or 3 or 4, the single member in an event, that is called the elementary event. And let us have one more with this compound event. Compound event means if you have more than. Compound event. Compound event means if you have in an event, if there exists more than one member, For example, if you make your event prime numbers 2, 3, 5 in case of the die experiment. So 2, 3, 5 has 3 members, 2, 3 and 5. So there are 3 members. 3 members means more than one member. That means it is a compound event. Now last but not the least, that is complementary event. Complementary event. Complementary event means, for example, let me give you an example. Again, same example. Throw a die. So your sample space is 1, 2, 3, 4, 5, 6. Throw a die. So your sample space would become 1, 2, 3, 4, 5, 6. Now, if my event is, let us say, even prime numbers, so I have 2, 3 and 5. So I am making my event as prime numbers. So E is the set of all 2, 3, 5. Now what is complementary event? Complementary event is denoted as E prime. E prime or E dash you say. E prime or E dash. This is the complementary event of this event. If my event is E, its complement is E dash, E prime, or you read it as E complement. Now it is what? Remember this? E dash, you call this E dash, you call this as E prime, you write it as E dash, E prime, or E complement. Now E complement is the set of all remaining elements from the sample space. That means it's S minus E. S minus E means all those which are present in S are not present in E. All members which are contained in S. Here, all members contained in S which are not contained in E. That is the subtraction. All members contained in S which are not contained in E. What are the members which are in S but not in E? 1 in S, not in E. So I have 1. 2 is in E. 3 E. 4 not in E. So I'll write 4. 5 yes. 6 not in E. So complementary event means all the remaining elements from the sample space. That means 1, 4, 6. If your event has 2, 3, 5, the remaining elements are 1, 4, 6. That means that is your complement. And remember one formula: probability of any event plus probability of complement of that event. It is also denoted as E bar. Remember this thing. E complement is also denoted as E bar. So it's also E bar. Got it? Now probability of event plus probability of not event. It is also read as not event. Not event. Complementary event is also called a not event. Probability of event plus probability of not event or probability of complementary event. That is always equal to 1. We'll see it in a while how it's possible, how it is 1. So that it was your complementary event. So we are done with the terminology. Now let us understand this concept: probability of event plus probability of not event. Not event is written as I just told you, E bar or E dash, is always equal to 1. This is equal to 1. Let us first have the technical definition of probability. Now probability mathematically is what? We just learnt that probability is the study of chance. It's a branch of mathematics which deals with the study of chance or the study of uncertainty. But probability is also, we call probability like this: number of probability is the ratio of number of favorable outcome to the total number of outcome. Now probability is the ratio of number of favorable outcomes to the total number of outcomes. Number of favorable outcomes to the total number of outcomes. So mathematically what we write? P is number of favorable outcome. We know favorable outcome is E. It is the set of favorable outcomes, number of E divided by number of sample space. So in short, probability is the number of elements present in the event divided by number of elements present in the sample space. For example, take the same example: samples throw a die. Now sample space is 1, 2, 3, 4, 5, 6. Now make event of prime numbers. So you have 2, 3, 5. Now you want the probability of this event. This is the event. Now probability of event means probability of some event. Probability of event. Write down here, probability of event is equal to number of event divided by number of sample space. Now here if you want to find the probability of this prime number, what are the chances? Now the concept goes like this. When you are, this is the real essence of probability. Now when you are tossing a die, you want to study the number of chances. What are the possible ways, what are the, well, yeah, or you can simply say what is the probability that you get prime number. When you are tossing a die, what are the chances that you get a prime number? That is the probability. What are the chances? Chances are number of E divided by number of S, because probability is the ratio of number of favorable outcomes to the total number of outcomes. We know number of favorable outcomes is what? It is the set of it is the set, that is an event, and total number of outcomes is what? It is a sample space. Now probability of event is what? Probability of event is number of E divided by number of S. Now you know what is E, you know what is S. E is an event, S is a sample space, both are sets. Now number of E means number of elements, number of points present in event. How many are there? 1, 2, 3. So write down 3. Divided by number of sample space. How many are there? 6. Now 3 by 6 is 1 by 2. So that's your answer. Probability of event is 1 by 2. That means what are the chances when you are tossing a die? What are the chances that you will get a prime number? The chances are 1 by 2. That means 1 by 2 times, if you do times 100, you will get a percentage. That will give you 50%. So there are 50% chances. So if you play 100, it goes like this. If you play 100 games, if you toss 100 times, chances are that 50 times you will get a prime number and 50 times you will get a non-prime number. You got it? So that is the real essence of a probability. Now probability of event is number of E divided by number of S. Let me give you one more example. For example, sample space of tossing a coin once. It is H, T. Now let us say my event is that head appears on the toss. Head appears on the coin. Now probability of E is what? Probability of E is number of E divided by number of S. Number of E means how many are there in event? 1. Yes. Number of S, how many are there? 2. So again 1 by 2 is the probability. You know there are 50% chances of head, 50% chances of tail. Now that is the point, that when you toss a coin, you have a 50% chances of getting a head and you have 50% chances of getting a tail. Now let us understand this. Probability of event plus probability of not event is equal to 1. Let us deal with the same example. Now what is probability of E? Probability of E means, let me first make E naught. First of all, I have a sample space because my experiment is tossing a die. Now if my experiment is tossing a die, so my sample space is 1, 2, 3, 4, 5, 6. Now I am making my event 2, 3, 5 prime number. Yes. Now make the complement of this event. E dash or E bar. The complement of event. What is my complement? Complement means the members which are not present in E are present in S. What are the members which are not in E are in S? 1. Yes. We have 4. Yes. We have 6. So this is the complement. Now I am saying find the probability of E. Probability means number of E divided by number of S. Now since my event is E, so I'll write number of that event. Whose probability the event whose probability you are going to find. You are going to take number of that event. So if my event is E, number of event here. If this is F, you'll write number of F. If this is G, you'll write number of G. If this is E complement, you'll write number of E complement. Yes. Now number of E divided by number of S. What is the number of E? 3. Divided by number of S? 1, 2, 3, 4, 5, 6. Yes. And you'll get 1 by 2. Now let us have probability of E bar. Probability of E complement. What is that? Number of, I just told you, if there is E, you have to write number of E. If there is E bar, you have to write number of E bar. Yes. Divided by number of S. Now number of E bar. What is the number in E bar? 1, 2, 3. How many members are present in E bar? 3. Divided by number of sample space. How many members are there in sample space? There are 6 members in sample space. Now that will give you again 1 by 2. Now therefore probability of E plus probability of E bar. Now do the addition. Probability of E, how much is that? What is the probability of E? It is 1 by 2, so I got it 1 by 2 plus probability of E bar, what I got? 1 by 2. Now do the addition. Half plus half is nothing but 1. So you proved the result that probability of any event plus probability of the complement of that event, it will always and always give you 1. Hence we proved that probability of event plus probability of not event is equal to 1. So that's it. See you next time. May Allah bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.